Welcome to Common Core Algebra II. Today's lesson is 10.9, Rational Inequalities. Now these are going to look a little bit like the inequalities we did earlier this year when we talked about linear inequalities and quadratic inequalities. But we're going to be talking about rational inequalities today. So exercise 1 says consider the rational inequality right here. All right, at what x value is the ratio equal to 0? So is this value part of the solution set? So we know that being equal to 0 means the numerator must equal 0. So x minus 5 equals 0. Obviously you can do this in your head, but you can solve it, the long way. Add 5 to both sides, and x is equal to 5. And it says, is this in the solution set? And there's no reason to think why not. So I would say yes, it is in the solution set. I'll say solution set, since 0, because when x minus 5, when x is 5, you get 0 over 3. 0 over 3 is greater than or equal to 0, and it does satisfy the inequality. But B says, at what x value is the ratio undefined? So when is this x value undefined? So that means when the denominator is equal to 0, it's undefined. So here x has to be negative 3. And it says, is this part of the solution set? And never. No. X equals negative 3 is not in the solution set, since the ratio is undefined at that point. All right, I think that's pretty straightforward. Now C says, enter the ratio in your calculator to help determine the values of x that solve this inequality. Plot the solution on a number line and state the answer in set builder notation. So we are considering x minus 5 over x plus 3, and we want to know when it's greater than or equal to 0. So it says to state it on a number line. And even though we don't always have to do it in the number line first, I think it's a really great first step before you move into set builder or interval notation. So let's go to the calculator. I've already entered it in, and you can see that we're looking for when the y values are greater than or equal to 0. So you can see all of a sudden when you start getting to numbers higher than negative 3 that we get positive numbers, and that's what we want. Now if you're not sure if, let's say 3.1 is in there, you can change your table set to see if it's going to be greater than or equal to negative 3, or simply, it wouldn't be equal to, it would be greater than or equal to negative 4, or simply greater than negative 3. And if we start going down, we have all these negatives, but then all of a sudden at 5, we start getting numbers, after 5, we start getting positive numbers back again. All right, so the calculator can help you decide that. So basically, when we go back to our number line here, our numbers are going to be negative 3 and positive 5. They're called our critical values. We'll get into that in a minute. Now, it cannot equal negative 3. We determined that. So that has to be an open circle, and it will be anything moving to the left would be in the solution set. And at 5, that is in our solution set because of this equal sign that's right here. All right, so this is okay, and it will be everything moving to the right. It says state your answer in set builder notation. So x such that x has to be less than negative 3, or x has to be greater than 5. Now you can use the word or in here instead of the symbol. That would be fine. I'm sorry, there was an equal sign there. We just talked about that. Okay, so write down what you need to, and I will meet you at exercise 2. So the key to solving rational inequalities is that they are compared to 0 that are compared to 0, is to find the values of x that make the numerator or denominator equal to 0. All right? These are called critical values, all right, of the rational expression. The rational expression can only change signs at these critical values. So in other words, when you make your number line, those are going to be your points that you're moving to and from. All right, so let's take a look at a little bit more difficult one. Solve the rational inequality. Solve the rational inequality for all values of x. Show your solution on a number line and state the solution set in either interval notation or set builder. We will do both. All right. So, of course, the first thing we're going to see is that rational expression and say, well, we have to make sure we have to find out when x squared plus 3x minus 4 is equal to 0. All right. And then we want to know when x squared minus 6x plus 9 is equal to 0. So let's see what happens here. I'm going to have an extra parenthesis here that I don't really need. So what happens here? I'm going to factor my numerator. And again, you can do this in your calculator. So you get x plus 4 and x minus 1. And over my denominator is going to be x minus 3, x minus 3. So if I take a look at this, my critical values, remember, you're looking at when they're equal to 0. So my critical values for my numerator is x is equal to negative 4 and positive 1. And in the denominator, I have a double root, which is positive 3. So these are my critical values. So it means that when I'm doing my number line, these are the values I'm going to point out. So negative 4, I'm not going to do this number line the traditional way. Here's 1 and here's 3. Okay, because we're just sketching this out. Now, because we're talking about less than 0, all right, where the denominator is positive 3, that has to be an open circle because that's when it's undefined. So the other values are also going to be open circles because it says it has to be less than 0. And the values of negative 4 and positive 1 will make the numerator 0. All right, the easiest thing to do here is go to the calculator and determine where your signs are positive and negative. So when we take a look at these on the calculator, remember what our critical values were? They were negative 4, positive 1, and positive 3. So let's see what happens in front, less than negative 4. So if you can look at less than negative 4, it's positive. Then between negative 4 and 0, it's negative. And then I'm going to slide down a little bit. I'm going to take a look at what happens after 1. And all of a sudden it starts getting positive again. And then look at our next one, which is positive 3. It stays positive. So we're okay that way. So when we take a look at what this looks like on our number line, this is where it's helpful to have your calculator next to you. So you can say, if you remember, it was positive here, it was negative here, it was positive here, and it was positive here. So we're talking about when it's less than 0, right here, less than 0. So that means that our solution set will look like this. And we don't have to worry about anything else. All right, so that's what it looks like. So now when you have to go to set builder notation, it's easy to recognize that this is a sandwich. The x is sandwiched between the negative 4 and the positive 1, like so. Then it also says you can do it in interval notation, which means, remember, if it's less than, it's going to have that rounded bracket, that rounded parenthesis. And then, again, you're going to have a rounded parenthesis at the positive 1. So that's interval notation. Either one of those would be acceptable in this answer. I know it's really hard for me to try and have you visualize this when you don't have your calculator in front of you, but take my word for it, and then in class tomorrow we'll make sure that you understand where those negative and positives come from. Things become more difficult if there exists more than one ratio, or if the ratio is being compared to a quantity other than 0. In both cases, it is important to algebraically manipulate the expression so that we are comparing it to 0. So just like when we did quadratics, you're kind of doing the same thing here. So this says solve the rational inequality and represent your answer using a number line and using set builder or interval notation again. So what we just said is this has to be compared to 0. So what we're going to do is we're going to take our 5 on this side. So let's write it all out so we make sure we're not. You're minusing 5 from both sides. Now don't let this confuse you. It's simply going to be x over x minus 8 minus 5 less than or equal to 0. All right, now you could use your calculator at this point if you had to. That would give you a really good idea about where your critical values are. But let's go back to using what we just learned about with fractional equations. So what's the common denominator? Remember, this is over 1. So my common denominator is going to be x minus 8. So I have my x from my left-hand side minus 5 times x minus 8 is less than or equal to 0. We're going to multiply that all out, and we're going to get x minus 5x plus 40 is all over x minus 8. So we get negative 4x plus 40 over x minus 8 is less than or equal to 0. So now we have one rational equation. So we can, one ratio. So at this point now we can follow the rules that we just talked about. So numerator, negative 4x plus 40 equals 0, minus 40. Negative 4x is equal to negative 40, and x is equal to 10. There's one of our critical values. And the other one is going to be x minus 8. It's where it's undefined. Has to be equal to 0, so x equals positive 8. So when we talk about our number line, we know our critical values are going to be at just positive 8 and positive 10. Those are our only two critical values. And once again, we're going to go to the calculator and see where the positives and the negatives occur. Now I'm going to remind you that this second one right down here is the undefined. So either way, that has to be an open circle. And at equals 0, because it can equal 0, 10 is going to be included in this solution set. So we know that already. So let's go to the calculator. So I put this in already. Notice when I put it in, I don't know if I can move this up, but I'm going to try. I don't know if I can move it up. Okay, well there it's highlighted. So you can see how I put in like the original one, x over x minus 8 minus 5. You can't have equals negative 5 because you can't have two equal signs in your graph. So I figure I can make less mistakes if I use the original. And so if I look here and I look at those critical points, 8 is one of them. We said that's undefined. And once again, I'm going to remind you, we're looking for where this is less than or equal to 0. So where it's negative. So as you can see, it's negative below 8, but then it becomes positive for 9. Come on, keep working. Why isn't this working? Here we go. Here we go. Okay, so 10 now becomes positive again when we start hitting 9, and then 10 it hits 0, and then if you look down just a little bit more, because you can't tell that 0.333 is actually negative, and negative 2, and negative 2.4, and so on. So when we go back to here, we realize that it's negative here, it's positive here, and it's negative here. So this is what our solution set's going to look like. So we want it to be negative, so it's going to go in this direction, and it's going to go in this direction. And again, this is really easy now to do your set builder notation. Now this is going to be an or because they're going in different directions, right, like the oars of a boat. So we have x is less than 8, or, we'll use the word this time, x is greater than or equal to 10. That's how you would write it in set builder notation. If you were going to write this in interval notation, it would be a soft parenthesis, 8, comma, positive 10 with a hard parenthesis. Oh, no, that's wrong. I'm sorry. I'm saying this wrong because this is an or. We need, I hate when I make mistakes. Sorry about that. This is negative infinity, comma, 8, or, duh, this starts at 10 with a hard parenthesis, starts at 10, comma, and then this goes on to infinity. Softly. Okay, that's right. I was just looking at this. You need, if you're going to have an or in your set builder notation, you need an or with your interval notation as well. So write down what you need to. Before we move on, I do believe there is an exercise 4. Yes, there is. Okay, exercise 4. Solve the inequality, solve the rational inequality, this right here, and represent your answer using a number line and using any appropriate notation. So you can use set builder or the interval notation. So this we're going to work on just the same way we did with equations. So we're going to find that common denominator. We're going to use the LCD approach, the least common denominator. So when I look here, I know my common denominator is going to be x times 2 times x plus 3. Because I need all of those to be part of my denominator. So we're doing that so we're getting rid of the fraction. So let's see if we can make sense of this. So we have x minus 1 over x plus 2 over x plus 3 is less than 3 over 2. So now we're going to multiply each of these. I'm going to protect these. We're going to multiply each of these by 2x, x plus 3. And this one by 2x, x plus 3. And this one by 2x, oops, x plus 3. So when you simplify this, the x's cancel. I'm left with my original x minus 1, but then I also have x plus 3 times 2 left over in that first one. Plus, the x minus 3's cancel. So I'm left with the 2x out front times my x plus 2, which is less than. Here the 2's cancel, so I'm left with my 3 and my x plus 3. I know this looks really long, but you'll see it really isn't that hard. Step by step, neatly and organized. So usually what I do with this first one here is I keep the 2 out front and I do my double distributive, and I get x squared plus 2x minus 3 plus, you can distribute this to 2x squared plus 4x less than, distribute this, I get 3x squared plus 9x. And one more time, I have to distribute this 2, so I get 2x squared plus 4x minus 6 plus 2x squared plus 4x is less than 3x squared plus 9x. We're going to combine like terms on the left-hand side of our inequality sign. So I have x squares here, which is 4x squared. I have 4x and I have 4x, which is a positive 8x. And I have that minus 6 left over there, is less than 3x squared plus 9x. And just like in the last problem, we have to make sure we get this equal to 0. So minus 3x squared minus 9x, which is going to give us the 0 that we need on the right-hand side. But whatever you do to one side, you have to do to the other side. Whoops, it's over here. Minus 3x squared minus 9x. So I get x squared minus x minus 6 is less than 0. So what do I have here? Now I have x minus 3 and x plus 2 is less than 0. So I have x is equal to 3 and x is equal to negative 2. These are my, in other words, these are my like my numerators where they're equal to 0. So they're going to be 2 of my critical points at 3 and negative 2. But then we also have to consider what makes the denominators of our original equation or inequality equal to 0. So we know that at undefined, we cannot have x being 0, and we can x not being -3. So those are always going to be, so 0 and -3 are also going to be critical values. So we're going to do the same thing here we did before. We're going to make our number line. We're going to include all of our critical values. So we start with -3, that's the smallest, then -2, then 0, then 3. All right. Make sure you put them in order. It helps. So then you go to your calculator. And again, you have to do the same thing we've been doing. I'm not going to waste your time doing that this time. But this is plus, this is minus, this is plus, this is minus, and this is plus. And because this is less than, these all have to be open circles. So what does this look like? We know this has to be less than 0. So it's got to be the negatives. So it's got to be in here, and it's got to be here. So let's write this in set builder notation. So x such that it's going to be 2 sandwiches. -3 is sandwiched between, let me just rewrite that because that looks poor. So is less than x, which is less than -2, or 0 is less than x, which is less than +3. So that's going to be, and you know what? I wouldn't even try to do this in interval notation because I think it would be too complicated, but I think you can still do it. It could be -3 to -2, all soft, or 0, +3. See, it wasn't as bad as I thought. So either one of those would be acceptable. All right, so we'll practice the part with the calculator when you come into class, and but the rest of it I'm hoping you'll understand. Just getting it equal to 0, very similar to the way we did inequalities with quadratics and how we did fractional equations, just the lesson before this. All right, so until I see you next time, always make good choices and be safe.